Greetings, everyone. Welcome to my talk on This Ain't Your Parents' Java. I'm going to talk about the current state of Java and where it's heading. And absolutely, I'm excited about where Java is heading. Well, let's talk about a little bit about where Java came from. Well, over the past 25 years, if you can even believe it, we've been into the 25th year of Java. And Java has come through a long way in this time. But I'm one of those people, I'll admit, on the other side of the picket line, constantly complaining that Java is not moving fast. Well, that all changed in the recent few years. Let's quickly talk about where we are and where we are heading. Well, Java has been through quite a bit of change over the years. I would say Java 5 was phenomenal, and then came along one of the biggest changes in Java, which was, of course, Java 8. And honestly, Java 8 is the one that really hooked me on to Java, even though I've been using Java for a very long time. And in the past in Java, we actually did imperative plus object-oriented programming. Well, today in Java, we can actually do imperative plus object-oriented plus functional style of programming. And that to me is exciting because functional programming reduces the accidental complexity in code, and we're able to focus on what to do instead of all the details about how to accomplish it. But of course, this wouldn't have been exciting if Java also did not provide us good performance with a functional style of programming. So what really blew my mind was the amazing lazy evaluation feature of Streams API. So by this time, of course, Java is already moving to a greater extent, catching up with a lot of languages. But of course, moving from there on, we also know what Java 9 provided for us. Now, Java 9, one of the most significant changes in Java 9 was, of course, the Java modules. And modules were really intended to modularize Java itself. It's not as much about you and me. It's really about the Java ecosystem. Well, before Java 9, if you look at Java 8, the rt.jar was a good 68 meg in size. Well, keep in mind, Java was created at a very different time 25 years ago than the times we live in right now. And we are living in the days of big data, microservices, function as service, Lambda computing, and so on. Well, with that said, how does the language change with time? And that's one of the reasons why Java modules is to really break this huge ball of mud, if you will, into more manageable, smaller pieces. And of course, to make Java more secure, more reliable. So a lot of these things were done from the ground up to Java to make Java better in terms of how you can function and go on for the next 25 years, if you will. And of course, a lot of interesting APIs that were part of Java 9 as well. So Java 9 was one of the most significant releases of Java compared to all the releases so far. So if you look back at the milestone of Java, I would say, of course, Java release itself was huge. And then Java 5 was really significant. Java 8 was really significant. And then you kind of wonder, wow, what's next? And came along Java 9 at that point. Now, clearly, there were other benefits in Java 9 as well, besides the ones I'm mentioning it. But to me, that was one of the really fantastic opportunities to see the growth of Java moving forward. Well, Java, of course, started accelerating a lot more since the time of Java 9. Yeah, that's absolutely a very important question to ask compared to Java 8 and Java 9. You know, which one is really an important version at this point? Well, I would say from the programmer's point of view, Java 8 was extremely important because it brought the functional style of programming to the Java platform. But on the other hand, this was still an opt-in and opt-out. As a programmer, you get to decide whether to use the functional style and when to use it. On the other hand, I would argue Java 9 was huge. It, in fact, affects every single person on this planet who has something to do with Java. And the reason is Java 9 modules are all about how we deploy the application, how we consume other libraries, how do we package. So even though it doesn't require coding effort, it is all about how we use Java. So I would say right now, the changes came about in Java 9 is probably the most significant overall, even though personally as a programmer, I still have my minds on the changes in Java 8 and the effect of it. But of course, one of the most controversial features, I would say, is in Java 10. Well, Java 10 has local variable type inference. Let me admit immediately to you, I love type inference. And the reason I love it is because I've used type inference in multiple other languages. So the fact that Java actually has it is really nice. But of course, not everybody views it that way for different reasons, and rightfully so, because every one of us come from different understanding and different backgrounds and different pain points, so it's natural. But let's talk about what's really Java 10 type, local type variable type inference. Well, let's say we create a greet variable and we assign it to a hello right in here. And I'm going to output the value of greet. And of course, no surprise here, it is greet. But make no mistake, if I were to call greet and say foo as a function, notice the error message we get. It says the foo is not available on the variable of type string. Obviously, this is all clear to us as Java programmers. However, instead of saying that greet is a string, I can simply say var. Now, I want to emphasize one thing, because sometimes programmers use words that may not be appropriate in describing this. I want to emphasize var is not a type. So there's no var type in Java. And I often playfully say the var is a wink at the compiler. You're winking at the compiler saying, hey, compiler, you know what the type of greet is. I know what the type of greet is. If you still want me to say it explicitly, I will, but I think you got it. So, and the Java compiler says, of course, I know what the variable type is. You can move on. You don't have to waste your time and effort in the ceremony. So when you run the code this time, notice that still worked. Of course, if you go back and do greet.foo one more time, notice the error that you get. The error is no different than the error you got a minute ago. And the reason I want to emphasize that is the bytecode generated in most situations is exactly the same whether you put the type or you did not. And I say most of the time because sometimes it's even better because the compiler is able to analyze a lot more. And of course, you may look at this and say, what's the big deal, Venkat? Why would you rather put a var instead of a string? What was the saving? Well, we saved 3 characters here, didn't we? Well, of course, that's not a huge benefit at all. But where this becomes really useful is when this is a really more complex type. For example, you have a list comma, let's say a list of, maybe even a map of, who knows, depending on the complexity of the application we are dealing with. And then you have a list of, and you have so many angle brackets, it leaves bruise on your, hands when you work with it. You don't have to worry about all of that complexity. You can simply assign it to a var and move on. And so here's the question. Are there limitations to using type inference in Java? And the answer is yes, there are. And some limitations, I would argue, are really good ones. And I'm in favor of those. And some limitations are more temporary, in my opinion. And that's going to change as time goes on, hopefully. Well, let me explain 2 examples here. One limitation we have right now is if you were to write a little piece of code, let's say OK here, just to see the compiler is happy with this. And you can see it is. Now, we saw that local variables can be inferred if you don't specify the type. But what about fields? So if I say max equal to 100, for example, the compiler is quite happy with it. But if I put a var here in this case, the compiler doesn't permit that. Well, that's a limitation, but I'm hoping that that's a temporary limitation because there's no reason why it cannot be inferred. Other languages actually do. On the other hand, one other limitation that Java has, and I'm actually in favor of this limitation, is that if you were to define a function, for example, and you have a variable that you're passing to this particular function for whatever the purpose is. Now, obviously, in this case, the code is okay, but you are not allowed to put a var right here. And I'm happy with it. Only few languages permit that, like Haskell. Well, don't get me wrong. I love Haskell, but not that part of Haskell because I feel a little nervous when the language infers the type of parameters to functions, mainly because I consider the parameters to be part of the signature, which is part of the interface, which I want to be well grounded and defined. So I'm really happy that limitation exists in Java. So there are a few limitations. Most of them are good. Some of them are more temporary, and I think they would go away as time goes on. So I'm really in favor of type inference, and I think it really makes the code easier to work with in the long run once we get used to it and once we use it judiciously. But having said that, we have a faster release cadence starting in Java 11, and every 6 months we got this bite-sized improvement to Java, which is really nice because unlike the past when we have to receive this huge deployment of Java, let's be honest about it. When Java 8 came out, I do this a lot among programmers. When I go to conferences, when I speak to developers, I ask them, what's really exciting in Java 8? And invariably, developers will immediately say lambdas and streams and functional style of programming. And it's really, I feel heartbroken in that because even though I love those features, not many people mention about completable future. That was such an amazing feature in Java 8. We tend to really not mention it, and it kind of went by the wayside, unfortunately. Well, that's what happens when we have a huge release of a language. Not everything really takes the same precedence. Well, that's being solved in Java thanks to frequent releases of Java. Now, of course, every 6 months we get a small bite-sized improvement. Let's pause for a minute and talk about that really quickly because sometimes developers get a little agitated about it. Now, they say, my gosh, how could Java be of quality if there is a development happening in 6 months cycle? Let me emphasize this really important point to keep in mind. Java is not being developed on a 6 months cycle. Java is being released on a 6 months cycle. There's a huge difference between the two. So it is taking as much time to develop a feature in Java as it did for the good quality for every single cycle. But the difference is if a feature took 5 or 6 years to develop, then it doesn't have to wait for another 3 years to synchronize artificially with other features to be released. So there's a release every 6 months. And when a feature is ready, as considered by the developers working on it, it doesn't have to wait for several years to release. It can go off in the next release, whichever is the next March or September that it is ready for release. So what that means is we as developers get to enjoy these features as soon as they are really available to the greatest quality. The developers also get satisfaction because they develop something that can be put to use right away and not have to wait for several years and be forgotten or really ignored in the long run. Now, in that regard, I honestly am so happy with some features in Java that's come out in the past few releases, 11 through 14, that is. And some of these features have been, baked through multiple releases as well to get the feedback. One example of that is text block that has gone through so many changes based on active feedback loops, which is really what the whole game of agile development is, isn't it? So Java is truly more agile today compared to years ago because it's feedback driven, it's incrementally being developed, it is really being done very sensibly. Well, enough of praising those efforts that's been done, which I think it deserves every bit of it. But let's get back to technical details here. Well, we've all had switches for a very long time, but let's step back for a minute. From the programming point of view, I love programming languages. You probably know this already. I am absolutely excited, not just about the syntax of languages, but the semantics, how we use them. So when it comes to programming languages, we deal with two different things often. One is the statements and the other is the expressions. Now, in terms of programming, statements, of course, are commands we execute. But if you really think about it, a statement doesn't return anything back to the caller. Well, what does that mean then? Well, by the nature of statements, statements force mutability. So if you're going to have a statement, the statement is going to force mutability or side effect if a statement is going to be of any use at all. Expressions, on the other hand, return a result to you, and they don't have to have side effects. They don't have to have mutation, and good expressions often are pure functions and they don't cause any side effect. Now think about this for a minute. If you think about functional programming languages do not offer side effects. And in that sense, really powerful functional programming languages don't have statements, they have expressions. But when it comes to Java, we have if statement, we have a for statement, we used to have a switch statement, and that is not really conducive for the functional style of programming, because all of these being statements are geared towards side effects, and that's hard to parallelize, hard to really use in pure functions, and there are negatives to it. Well, I cannot tell you how excited I am that switch is no longer a statement. Now, clearly, if you want to use it as a statement, you can, but it can be used as an expression as well. So let's look at an example. Let's go ahead and say call a process and pass a 1 to it right here. I'll keep this example really simple, and I pass a 2 and a 3, let's say. Now, I want to be able to use this switch in here. So I'm going to say, use this expression of a switch in here as an example. So let's create a little example of return a string from a process function. It takes an integer as an input, but what I'm going to do here is to simply say return, and I'll say switch on the input like that. Now, I cannot tell you how excited I am to be able to see the word return in front of the switch. That makes the switch an expression, as we know. And then using a very concise and elegant syntax, we can simply say if it's 1, simply return, let's say, first, if you will. And I can say if it is a 2, maybe return a second, if you will, right in here. And then, of course, I can also say if it's everything else, default, I don't really care what else is, and I'm going to simply say whatever over here and return it. So in this case, we can use that as an expression. Now, clearly, there are times when we want to take a single path for different combination of values. And if you do, you can certainly do that by combining them together, for example. So first or second, if you will, and we can combine them together as well. So the syntax is really concise, and as a result, all those nasty, huge if and else statements we often end up writing simply go away, and we can make the code very concise and expressive. What's even more exciting is it's a very small step for the version of Java, but it's a giant step for programmers in the future. And the reason is this is going to eventually lead into one of my favorite features in programming languages, which is really pattern matching. And that's, we'll talk about a little bit later on and see what that can provide for us. So switches are really phenomenal. As you can see in this case, they are pretty useful as a switch expression. Now, moving a little further in here, what about text blocks? Now, I'm sure every one of us have done this. Nothing to be really proud of. We say string message is equal to this is a text, and then we come back and say message plus equal to some more. And then we may add, when you're creating a document of some sort, and then message plus equal to, more text and so on. We all have done coding like this. Now, this is a code we would hide from our children, because if they ever walk into the room and take a look at what we do, they would never want to take after our profession, seeing the type of code we write. This is not something to be proud about. This is not a code you want to go show to your friends, especially who are programming in other languages. Well, the good news is we don't have to endure that pain anymore. Let's take a look at an example in here just to see how. Let's create a message, if you will. And the message we're going to create is for our good friend Sarah. So what do I want to tell Sarah? Well, in this case, I'm going to create a function, public static. It returns a string. And here is the message function, which takes a name. We'll come back and work on the name in just a minute. But I'm going to say return. But notice I put three double quotes. Now, some languages call this as here docs. So here docs has been around in other languages for quite a while. And when Java was trying to introduce this, they really wanted to introduce here docs, but then they realized that the use case should be a lot broader. And so they deferred the availability of this to go back and improve it. Again, the feedback loop I mentioned. And so now this is a multi-line string, which is really powerful. So what we can do in here after the three double quotes is simply say, hello there, welcome to the world, let's say, world of modern Java. Great to have you here, right? So it's really a multi-line string you are able to create. And in this case, when I execute the code, what does it tell us as the output? Notice it tells us, hello there, welcome to the world of Java. That multi-line string came out really nicely in here. We didn't have to do a lot of work at this point. Now, obviously, you say, what about the name? Don't we want to bring that in here? Well, clearly that's something we want to bring it in here. So I'm going to go back here and say string.format right there. And I'm going to go ahead and format around that multi-line string we just created. And I'm going to say comma name, and then drop the name right there into that area. So now it says hello, Sarah. And so we can even embed expressions in there as well if we really wanted to. Now, on the other hand, you could have as much as you wanted to. This could be an XML document you create, could be a JSON data you create. It could be, where I use this often is, let's be honest about it. We all are in this flood of emails that we go through. And if I were to send you an email, I can do hello and drop you an email. But you know what? I like to get really personal with people to refer them by name. I often do. And honestly, most of the time, I type the email because, hey, I'm taking the time to communicate with somebody, I'm going to do it. But if I'm going to be sending an email to 20 or 30 people, often I do to my students, I do to my clients. And then, of course, it's really hard for me to sit and type every name. That's error prone as well. Well, guess what I do? I have a little program in the background, all automated, and simply wakes up and fills the name of the person and then sends the email. So now I can send very specialized email to people thanks to features like this. And in fact, features like this even make it easier for me to spam people as well. No, just kidding. Well, we can actually reach them and customize the messages very nicely, as you can see. So that's basically one of the real nice benefits of having a text blocks, if you will. Now, of course, that's really an important question to ask. I mentioned earlier that text blocks have been around, like here docs in other languages. And this is one of the questions often developers ask is, gosh, is Java just taking stuff from other languages and using it? I have a very different view of that. Language developers have to constantly learn from each other to create these features. So it's not a question of copying over, it's a question of learning from other languages and bringing them over. But I have to tell you, I've got the deepest respect for Java, maybe in a slightly different way than others do. Now, Java was definitely, as we know, not the first language to introduce lambdas. And likewise, Java is not the first language to introduce text blocks. But when I look at those features, I don't just look at them and say, okay, big deal, they were in other languages, they are here now in Java. I always ask the question, how is it different in Java? How is it better in Java? For lambdas, for me, that was invoked dynamic. For text blocks, similarly, I was curious about it. And what blew my mind with text blocks is text blocks rather, did not simply adopt the feature from other languages and say, here you go, others do it, we did it too, it's yours. Instead, they actually took time to make this much more powerful. And they not only saw what other languages do, they also saw where they maybe not do very well and went on to improve it. In that regard, notice one thing you saw here. If I were to go back to this code and say, hello right there, and I run the code, notice the lowercase hello and the uppercase hello are lined up together. Now, clearly, notice the code in here. We have this indentation sitting right there, but Java sensibly removed that indentation. I cannot tell you how happy I was when I learned of that feature, because I've used HereDoc in other languages and I waste my time stripping out those indentation in those languages using whatever syntax or API they provide. And when I saw Java do this, I'm like, thank you, this is amazing. And to me, that is where the innovation is, not just creating new features, but making them really sensible and easier to use for developers as well. Now, of course, if I indented that part right here, as you can see the indentation take shape. So it's extremely good algorithm to determine where the indentation should be and where it shouldn't be. Similarly, there are other features with this to deal with end of line and spaces in the end and so on. So very powerful and very sensible operations being done in that regard. Now, moving a little further, one of the other features that I'm absolutely thrilled for is records. So what really are records and what are we going to do with them? Now, suppose you are interested in writing a class in Java, like a class called person. Now, what does a person contain? You can say private, you can say final, we can say string first name, and we would write the first name right there. Then we would similarly go ahead and write the last name after that. And once we do, what do we then do? We write getters for it. So we'll say, string get first name, you would write that code, isn't it? And then, of course, what would we do with this one? We would say return first name, and we're going to write that. Now, after writing this, of course, we're going to write another function for the get last name. Then, of course, if you really find a reason to implement the equals method, you write the equals method, but don't forget to write the hash code method as well. Well, then, of course, you probably write the toString method. And by the time you are done with all of that, we forgot what we started doing in the first place. That's a lot of effort, lot of typing. Now, you may say, oh, come on, Venkat, I don't do that. I instead define that variable, and then I gently right-click on it, and then my IDE vomits the rest of the code. Well, you have to live with that vomit forever every time you come and look at this code after then, unfortunately. Or you may say, oh, no, I use third-party libraries that will generate this under the hood for me. Yes, you have to use a third-party library for that. Why can't the language do that for us after all? Well, that's exactly what Java does with records. We know this as data classes in other languages, sometimes as case classes, but these are classes for which the getters and setters, well, getters are created automatically. The equals and the hash code and the toString are created automatically. These are really useful for data objects. That's what they really are. So for example, I can say record person, string first name, and then a string last name right there. And of course, in this case, I created those two as a variable at this point. Now I can simply say something along the lines of person equal to new person, let's say Alan comma Turing right in here. So when I create this Alan Turing and I output the person, well, notice at this point, the person name, the toString method shines here, that's already provided. But I can also ask for the property, which is the first name. The getter is given for me automatically as well. I can use the the first name from this person in here as well automatically and print it. I'm not sure exactly why I got that error. Well, maybe because I forgot to put the parenthesis. There you go. So that's basically, it says Alan right there. That's a property we are getting out of the object. Well, as you can see in this case, not only can you do this, you can also specialize a constructor for this as well. For example, you can say public person, and then you can say in this case, for instance, creating, and obviously you can put code in here to access the details of the first name and so on, and you can perform error checking at this point if you really wanted to. So very highly concise piece of code, and records are amazing. Oh, that's a brilliant question. Records are nice. They reduce the boilerplated code. Sure, you are right. They remove all that ceremony without need for ID support, without need for third-party libraries. But your question here is, are there any benefits beyond reducing boilerplated code? And the answer is, of course, very yes. And that's one of the things that excites me about records. Records actually are going to play a really vital role when pattern matching is available in Java. Imagine you have a record of some data, a message you are receiving, and in the pattern matching syntax, you are saying if the data received is this record type, then pull the object's properties for me. Where this is going is to another feature that absolutely I love in other languages, and I'm really looking forward to this feature in Java in the future. That feature is called deconstruction or destructuring. And destructuring gives an opportunity for us to extract the properties from objects in a very concise manner. And records mixed with pattern matching is something I can bet you I'm longing for that day when that's going to become available in Java, and that's going to come to us in the next few versions, or I'm hoping that it's going to come sooner than later. So this really, as your question suggests, is opening up door for not just improvement now, but for things we can do in the future as well. Well, that leads us to one other amazing capabilities to reduce ceremony. Let's look at an example here. Suppose I call a function again process, and I'm going to send a hello to it, and call a process and send a 1 to it. Maybe this process is receiving some messages and it's going to work with it. So if I were to code this code process function, let's take a message of any type that's coming in. And what am I going to do in here? I'm going to say if input is an instance of string, then what am I going to do in here? I'm going to say output got a string of length, and I want to say what the length of that string really is. So to do that, I'm going to say plus and input dot, in this case, input dot length, and ask for the length at this point. Now, when I run the code this time, I get an error. Now, what happened in here? Well, I cannot call length on an object because length is not a property on the object. And of course, you all know what to do with this. You're going to now take that one and you're going to perform the casting around that particular variable in order to use it. Now, some people call it casting. I call it punishment. Now, this is where the compiler is really not working with us. You know, would you be happy with somebody who speaks like this? You go to them and say, did you go to the movie yesterday? And they say, yes, I did. And you say, how was it? They say, how was what? And you're not going to have a conversation after that, right? Well, that's what this code is doing. Is it a string? You said yes. And you said, what's its length? It says length of what? Well, come on, you can't forget so quickly. Well, you can change that very nicely by simply telling to use a smart casting. So you can say, all right, now notice got a string of length 5. And essentially you said, hey, you are really using the string as a placeholder for exactly that variable. They both are the same instance under the hood, but on this point, you have a reference to that variable with type string, so you can liberally use that within that block of code. Or if you're using that in a ternary operator, you can use that as well. pretty nice feature, as you can see, something that's going to make code a lot more concise and much more elegant and low ceremony as well. It feels like we are programming more intelligently. Well, I talked about where Java is today with a lot of these features. I want to quickly talk about where Java is heading and why. Well, this is one of the things I appreciate with Java is the developers behind the Java language are not really interested in moving Java faster at any cost. Instead, they're asking the question, what features are useful? What features are feasible, and what features can we implement today in a way we can sensibly support it moving forward, and at the same time can be backward compatible to features we already have. So their growth of Java is very pragmatic rather than being reckless, in my opinion, and I have the deepest respect for that. And of course, I talked about the short release cycles earlier on, which is really a wonderful opportunity. And of course, Project Panama, these are being experimented using different project names, and Project Panama is introducing features which are foreign functional interface. Imagine the ability to do JNI or remote calls without having to endure the pain where your functions may be written in other languages and you can naturally use them in your Java code without a lot of effort and pain. Well, that's kind of an improvement that we can look forward. Project Valhalla, on the other hand, focuses on providing value types. I cannot tell you how eager I am for this. And this gives us an ability for us to really use the value types as in where we can have maybe one day generics that are really of integer types and so on can be extremely powerful as well. So that's amazing feature looking forward. And Project Ember is reducing a lot of ceremony and verbosity. And I cannot tell you how thrilled I am for two features that are going to come out in the future. One is sealed classes, which are useful for abstract data types where you can say, hey, here is a class which is an abstract class, anybody can inherit from it. Here's a final class, nobody can inherit from it. But a third combination, here's a class with only these derived classes and no other. So you can confine the grouping of abstractions. This is really the concept of abstract data types that you have in the case of languages that you're able to bring together very powerfully to say, for example, you create a card and you can say what kind of cards can be and not some arbitrary thing developers can create. And this is not only useful for better abstraction, that's going to play a really vital role in pattern matching as well. And of course, pattern matching is phenomenal in terms of how we can take the patterns and without writing verbose if and else statements, we can nicely pattern match and very concise, elegant syntax. And of course, I don't think I'm as excited about anything in the future as Project Loom, where we're going to have continuations and fibers. This is going to redefine how we're going to do asynchronous programming in the future. If you're really interested in fibers, the next talk coming in the series is on Project Loom and fibers and continuations. So stay tuned for that. But this is going to fundamentally change the way we do asynchronous programming in Java. And it's also going to redefine what we view as scalability. So I'm absolutely thrilled for it, where we are heading and where Java is heading. One question here is, what will make the Java language more approachable, both to existing Java programmers and new developers to Java? That's a really important question. I spend my time in consulting and training developers and organizations, and I have to tell you how many times I meet developers who are actually coming from other languages, Python, for example, or coming new to Java, having gone through maybe an education. And when they look at the ceremony, they often get put off. So to me, one of the most significant things that Java is going to provide is removing all that boilerplated code and ceremony and make the language more approachable. In all honesty, Java is doing that already, and that's trend is going to continue moving forward. So, more secure, of course, is very important for enterprises. More approachable is really removing the ceremony, making the language more sensible where the programmers can spend more time focusing on the domain and the business logic rather than trying to make the language compiler happy with its expectations and requirements. So the trend that started a few years ago in removing the verbosity of the language, I think that trend is going to continue, and Java is only going to become more approachable. And think of this is a beautiful combination of one of the most powerful languages, one of the most popular languages is also becoming easier to use. How many languages can we look at and say it's getting better as time goes on? Well, Java is certainly one of those languages. Well, I want to thank you for the time. I hope this was useful. I'm absolutely excited about where Java is. I've been programming in Java for, almost as long as the language has existed. And clearly, I see next generation of programmers using the language right now, and their needs and their expectations are not the same as what I used to have. So that's why I call this, it's not your parents' Java, it is the Java for the next generation. And I'm absolutely excited about it. And I hope you are as well. So thank you so much for joining. Well, some exciting talks coming your way in the next presentation in the series. So look out for continuous monitoring with the JDK flight recorder by Michael Wilstrid. And then also look for Project Loom, which I mentioned earlier, and more scalable concurrency for the Java platform by Ron Pressler as well. Thank you again for joining. Best wishes, greetings.